All right, we want to solve this systems of equation by elimination. We could use graphing, we could use substitution, but because both equations are written in standard form, it's going to be easier to eliminate one of the variables. If we want to eliminate x, we can't just add or subtract the two equations. This is 3x, this is 2x, they're not the same, so we can't add or subtract them. 3x and 2x aren't multiples of each other, so we cannot just multiply the top equation by a number, or we cannot just multiply the bottom equation by a number. To eliminate x, we'd have to multiply both the top and the bottom equation. To do that, or to figure out what we multiply the top and the bottom equation by, is we think of the least common multiple between the two terms. So between 3 and 2, our least common multiple is 6. So we want to multiply the top equation by a number in which, so that we get 6x. So if we multiply the top by 2, we're going to get 6x plus 8y equals 114. Again, we want 6x for our bottom equation. So in order for us to get 6x in our bottom equation, we're going to have to multiply that by 3. So 3 times 2x is 6x minus 15y equals negative 93. Now we have the same number for our x term, so we can eliminate x. Since both of them are positive, we're going to subtract the second or the bottom equation. So 6x minus 6x is 0. We've eliminated the x. 8y minus negative 15y gives us 23y. And 114 minus negative 93 is 207. And so now we divide by 23 and we solve for y. So y is going to equal 9. So now we got to figure out what x is, so we substitute 9 in for y. Again, it doesn't matter top or bottom. Let's use the top. So 3x plus 4 times 9 equals 57. 3x plus 36 equals 57. We get 3x is equal to 21, so x is equal to 7. So our solution to this is 7, 9. Now, we don't have to eliminate x. If you wanted to, we could have eliminated the y term. So we'll also do this problem again. This time we will eliminate the y term. So on the last one, we eliminated x. On this one, we could also eliminate y. And again, like with x, we can't just add or subtract the two equations because our y values are not the same. 4y and negative 5y are not multiples of each other, so we cannot multiply the top equation, or we cannot multiply the bottom equation. So again, we think of the least common multiple. The least common multiple between 4 and 5 is 20. So we're going to want to multiply the top equation by something so that we get 20y. And if we multiply the top equation by 5, we will get 20y. So 5 times 3x is 15x plus 20y is going to equal 285. So now we want 20y for the bottom, or the second equation. So to get 20y, we're going to have to multiply the bottom equation by 4. So we're going to get 8x minus 2y is equal to negative 124. So now we have 20y in both equations. Since one is positive and the other is negative, we can add our two equations to eliminate the y variable. 15x plus 8x is 23x. We've eliminated the y. 285 plus negative 124 gives us 161. And now we want to solve this for x. So we divide by 23, and we get x equals 7. So now we plug that into one of our equations. It doesn't matter which one, and we solve for y. I'm going to plug it into the top equation. 3 times 7 plus 4y equals 57. 21 plus 4y equals 57. 4y equals 36, and so y equals 9. So our solution is 7, 9. And we got that the last time. So it does not matter which variable you want to eliminate. You could eliminate x, you could eliminate y. You'll still get the same answer.